The launch of the James Webb Space Telescope wasn't just a milestone, it was a cosmic game-changer. As the next-gen successor to Hubble, Webb came packed with cutting-edge tech that lets us peer deeper into space than ever before. Its superpower? Seeing infrared light, which means it can look straight through cosmic dust and reveal parts of the universe we've never seen. And when its first images dropped, they didn't just confirm what we thought, they blew our minds wide open, revealing a universe far more vast and complex than we ever imagined. This isn't just science, it's the future of space exploration. Before we dive in, make sure to smash that like button and subscribe for more mind-blowing space updates. The James Webb Space Telescope didn't just open a window to the universe, it blew the roof off our understanding of it. From the very first images, Webb revealed a cosmos that was far busier, messier, and more dynamic than anything we'd imagined. Where older telescopes showed faint, fuzzy blobs, Webb delivered crystal-clear views of tightly packed galaxies, intricate stellar nurseries, and ancient light that's been traveling for over 13 billion years. And these weren't just pretty pictures, they shook the foundations of modern astronomy. One of Webb's most jaw-dropping discoveries? Galaxies that formed shockingly early in the universe's history, just a few 100 million years after the Big Bang. That's way ahead of schedule, according to current theories. These early galaxies weren't simple either. They had spirals, bulges, and even dust, which scientists thought took much longer to develop. This forced astronomers to rethink how quickly cosmic structures can form. Either the universe was building galaxies faster than expected, or we've been missing key pieces of the puzzle. Adding to the mystery, Webb spotted supermassive black holes at the heart of some of these young galaxies. How did something so massive appear so soon? These findings challenged long-held beliefs about how matter gathers and evolves in the early universe. Then came another revelation. The universe is way more crowded than we thought. Regions of space once considered empty turned out to be bustling with galaxies, stars, and matter in motion. Thanks to Webb's enormous mirror and infrared vision, we could now see objects so distant that their light left them billions of years ago, offering a direct look into the universe's infancy. And each of those tiny points of light? Often entire galaxies, each one home to billions of stars and possibly planets. But Webb didn't just show us what's far away, it also zoomed in on the action closer to home. Inside our own galaxy, it peered through thick clouds of gas and dust to witness the birth of stars and planets. In places like the Carina Nebula, Webb captured scenes of young stars blasting out radiation, shaping the clouds around them, and revealing the raw, chaotic beauty of stellar creation. Perhaps the most awe-inspiring takeaway from all of this? Realizing just how vast and varied the universe really is. Webb uncovered galaxies with bizarre shapes, cosmic structures stretched and twisted by gravity, and massive filaments of gas weaving across space like the skeleton of the cosmos. These aren't just distant curiosities, they're clues to how the universe is built. In the end, Webb's discoveries don't just deepen our understanding of space, they challenge how we see ourselves. In a universe teeming with ancient galaxies and unfolding mysteries, our pale blue dot feels even smaller. But through Webb's lens, we're also part of something unimaginably grand and just getting started in understanding it. When the James Webb Space Telescope turned its gaze toward a seemingly blank patch of sky, it revealed something astonishing, a vibrant ocean of galaxies stretching far beyond what we ever expected. That moment underscored a humbling truth. What we see is only a fraction of a much grander, possibly infinite universe. But Webb didn't stop there. Its powerful instruments began probing the atmospheres of distant exoplanets, worlds orbiting stars light years away. Using spectroscopic analysis, think, breaking light into its chemical components, Webb detected signs of water vapor, carbon dioxide, and methane, key ingredients that hint at the potential for life. While this isn't proof that aliens are out there, it's a thrilling step forward in the search for habitable worlds beyond Earth. Thanks to Webb's extreme sensitivity to subtle shifts in light, scientists are now able to study these alien atmospheres with unprecedented detail, helping to narrow down which planets might be worth a closer look in the future. And then there's the cosmic magnifying trick. Gravitational lensing. Webb captured stunning examples of this phenomenon where massive galaxies and galaxy clusters act like natural zoom lenses, bending and amplifying the light from objects even farther away. This allowed astronomers to glimpse ancient galaxies that would otherwise be too faint to detect, giving us a deeper view into the early universe. These lensing effects also offered valuable clues about the invisible scaffolding of the cosmos, dark matter, revealing where unseen mass bends the very fabric of space. But perhaps one of the most exciting breakthroughs came closer to home, in the chemistry of space. Webb identified complex organic molecules, the building blocks of life, within star-forming regions, icy comets, and even asteroids in our own solar system. These discoveries suggest that the ingredients for life might not be rare at all. They could be spread all across the cosmos. The images Webb delivered weren't just pretty snapshots. They captured a universe in motion, galaxies crashing into each other, stars being born in glowing clouds, supernovae tearing themselves apart, gas and dust spiraling and shifting through gravity's invisible hands. Through subtle time-lapse changes and fine details, Webb let us witness cosmic drama unfolding in real time. In short, the James Webb Space Telescope isn't just a telescope, it's a time machine, a chemical lab, a cosmic detective, and a window into the deepest mysteries of the universe. And with every new discovery, it brings us one step closer to understanding not just where we are, but how we came to be. Imagine sending a massive observatory nearly 1 million miles from Earth to a stable point in space called L2, where it had to unfold like a piece of origami in zero gravity. A sunshield the size of a tennis court, 18 separate mirror segments aligning with nanometer precision, and temperatures close to absolute zero, all had to work flawlessly. That's exactly what happened. Every crisp image and stream of data isn't just a peek into the universe, it's a standing ovation for the teams of engineers and scientists who made the impossible possible. Webb's unmatched clarity allowed it to do something no telescope before it could: see through cosmic dust. What once blocked our view became transparent under its infrared gaze. Where Hubble saw only shadows, Webb revealed hidden galaxies colliding, stars being born, and planets potentially forming in swirling disks. Dust, once the enemy of astronomers, became a treasure trove of cosmic clues, telling us how matter moves, transforms, and recycles through time. With every new discovery, Webb pulled back the curtain on the universe's deepest mysteries. Its powerful eye didn't just look across vast distances, it looked back in time. The ancient light it captured told stories from the universe's earliest days: the birth of the first stars, the formation of key chemical elements, and the awakening of galaxies that lit up the cosmos after its long dark ages. But the telescope's impact isn't limited to the world of science. It touches something deeper. Webb reminds us that the universe is older, larger, and more dynamic than we ever imagined. It shows that cosmic change is fast, chaotic, and beautiful, and in doing so, it challenges us to rethink where we fit in this epic story. Just one small planet, in one ordinary galaxy, in a universe bursting with complexity and wonder. It revealed a cosmos that isn't just ancient, but astonishingly complex from the very beginning. Galaxies weren't slowly assembling over time, they were forming fast with surprising sophistication. What we once thought of as empty space turned out to be alive with detail, color, and motion. With every discovery, Webb didn't just add to our knowledge, it reshaped it. This telescope expanded our timeline of the universe's evolution, showing that galaxies and stars emerged far earlier and more rapidly than scientists had predicted. It captured not only the vastness of space, but the richness woven into every corner of it. Webb showed us that the universe isn't just big, it's brilliantly intricate, and we're only at the beginning. As more data rolls in, each new observation opens up new questions. Webb is more than a telescope, it's a cosmic storyteller, rewriting everything we thought we knew about how the universe works. Its lens doesn't just reach across billions of light years, it connects moments, processes, and patterns that reveal a universe constantly in motion. One of the telescope's most groundbreaking achievements is its ability to observe not just what's out there, but how it changes over time. With long-duration observations, Webb brings time into the equation. We can now track how stars live, evolve, and die, not just in our own galaxy, but in distant corners of the universe. From exploding supernovae to flickering variable stars, Webb captures space as a living, dynamic place. What once seemed like still snapshots of deep space are now part of an unfolding cosmic film, one where each frame reveals something new, strange, and deeply profound. Webb isn't just observing the universe, it's revealing the choreography of creation itself. When it turned its powerful infrared gaze towards starburst galaxies, those wild, energetic galaxies churning out new stars at breakneck speed, it revealed much more than crowded stellar nurseries. It exposed something unexpected. Long rivers of glowing gas streaming far beyond the galaxies themselves, connecting them to the vast cosmic web that binds the universe. These flows weren't just beautiful, they were clues. They showed that galaxies don't grow up alone. They interact, exchange matter, and shape one another across billions of years, forming a kind of intergalactic ecosystem. Webb also gave us a front-row seat to some of the most dramatic events in the cosmos, galactic mergers. What once looked like fuzzy smudges now burst into view with stunning clarity. You could see twisting tidal tails, glowing shockwaves, and vast regions erupting with new stars. In these violent collisions, galaxies are reshaped, spirals stretch, bulges build, and black holes grow. Far from being rare or random, these cosmic crashes are a key driver of galaxy evolution, proving that chaos creates. But the surprises didn't stop there. As Webb scanned the sky, it began uncovering strange and ghostly galaxies, ones so diffuse they were nearly invisible before. These ultra-diffuse galaxies, made mostly of dark matter with only a sprinkling of stars, challenged old assumptions about how galaxies form and what holds them together. Even stranger? Some galaxies appeared to have no dark matter at all, raising big questions about how gravity really works at cosmic scales. Webb also dove into the invisible realms of black holes and neutron stars. While these objects can't be seen directly, Webb captured the effects they leave behind: light bending, material swirling, and X-ray echoes marking their presence. These subtle signatures allowed astronomers to locate and study them more precisely than ever before. In every direction it looks, Webb reveals a universe that's more connected, more active, and far stranger than we ever imagined. Galaxies don't just exist, they interact, collide, evolve, and surprise. With every observation, Webb helps rewrite our understanding of how the cosmos lives and breathes. In places once thought cold and quiet, where stars had long since died, Webb uncovered glowing disks of dust and gas swirling around black holes and neutron stars. These accretion disks, captured in crisp infrared detail, revealed that these objects are still feasting on nearby matter. Some binary star systems even showed dramatic outflows, jets of energy blasting into space, and extreme gravitational effects that aligned beautifully with Einstein's theories. These snapshots aren't just visually stunning, they're rewriting what we know about the end stages of massive stars. At the same time, Webb has gone far beyond expectations in the realm of planetary science. Its observations of exoplanet atmospheres, planets orbiting stars beyond our solar system, have been groundbreaking. By watching starlight pass through these atmospheres, Webb detected not only water and carbon dioxide, but also rarer molecules like sodium, sulfur dioxide, and even silicates, hinting at possible clouds made of rock or volcanic processes. These chemical signatures offer tantalizing clues about alien weather, geology, and maybe even signs of life. Some planets showed atmospheric imbalances, chemical makeups that couldn't be explained by natural processes alone. While it's too early to say if life is responsible, these anomalies have scientists buzzing with excitement about what might be out there. Webb didn't stop at single planets either. It's capturing entire planetary systems in motion, dusty disks forming rings, gaps hinting at unseen planets, and even signs of exomoons and Trojan asteroids, cosmic companions sharing planetary orbits. These fine details are helping astronomers piece together how planetary systems evolve and how they compare to our own. One of the most surprising discoveries: rogue planets, worlds drifting alone through space, not tethered to any star. These loners, long suspected but hard to spot, were clearly visible to Webb thanks to their faint heat signatures. Their presence suggests that planet formation is messier and more diverse than once thought. Some may have been ejected from their home systems, others may have formed in isolation. Either way, Webb has shown that stars aren't the only birthplace for planets. When Webb turned its powerful gaze toward the planets of our solar system, it revealed astonishing new details, proving that even our celestial neighbors have plenty of secrets left to tell. On Jupiter, Webb captured swirling storms and shimmering auroras, lighting up the poles in stunning infrared clarity. It spotted volcanic heat glowing on Io, the most geologically active moon, and peeked beneath the icy shell of Europa, searching for clues of hidden oceans that might cradle life. Saturn's iconic rings came into focus like never before, showing evidence of tiny impacts from micrometeoroids, cosmic pebbles constantly reshaping this planetary jewelry. Moving outward, Uranus and Neptune, long shrouded in mystery, had their atmospheres peeled back, revealing distinct chemical layers and patterns. Even the distant icy objects of the Kuiper Belt, relics of the early solar system, were brought into view, time capsules of the primordial past. But Webb's talents didn't stop with planets and moons. It also changed how we see one of astronomy's oldest adversaries: cosmic dust. Where telescopes once saw dust as a frustrating obstacle, Webb revealed its starring role in the grand story of the universe. With unmatched sensitivity, it traced how dust births stars in cold clouds, gets scattered by supernova explosions, and carries the building blocks of new planets and galaxies. Whether floating in deep space or swirling around dying stars, this dust turned out to be one of the universe's most important storytellers, showing how matter cycles through creation, destruction, and rebirth. Another breakthrough came from Webb's glimpse into the ancient universe during the mysterious age of cosmic reionization, a time when the first galaxies helped lift the fog of the early cosmos. Webb spotted some of the very first galaxies to shine, and by tracking their ultraviolet light, scientists began to piece together how they slowly transformed the dark, neutral universe into one glowing with stars. It wasn't a sudden event, but a cosmic dawn that spread like scattered lanterns, lighting up a vast, foggy landscape. With its ultra-detailed spectra, Webb allowed scientists to measure how much ionizing radiation was escaping from young galaxies and how that light shaped the surrounding hydrogen gas. These insights are helping to fill in the missing pieces from one of the most mysterious chapters in cosmic history, the era of reionization, when the first light broke through the early universe's fog. But Webb's reach didn't stop there. While it wasn't built to detect dark energy directly, the strange force pushing the universe apart, Webb has helped map the cosmos with unprecedented clarity. Its deep space surveys allow astronomers to chart the expansion of the universe with incredible precision, offering new clues about how this expansion has changed over time. These measurements are critical to understanding whether dark energy behaves the same everywhere, or if it might evolve or vary in different corners of space and time. Webb also helped shine a light on a long-standing cosmic mystery: intermediate mass black holes. These missing links between small stellar black holes and the supermassive giants at galaxy centers had been mostly theoretical, until now. With Webb's sharp eye, astronomers could zoom into dense star clusters and track the gravitational movements hinting at these hidden giants. Unlocking their secrets could reveal how supermassive black holes came to be in the first place. As Webb gathered more data, it also began challenging old assumptions. It uncovered bizarre celestial objects that didn't quite fit into any known category. Galaxies behaving like both spirals and ellipticals at once. quasar-like objects missing their usual radiation signatures. These weren't just cosmic oddities, they were signs that our current way of classifying the universe might need a serious update. Perhaps most exciting of all, Webb didn't just solve mysteries, it sparked new ones. Its discoveries are already shaping the next wave of space missions, from exoplanet explorers to deep space probes. By expanding what we know, Webb is paving the way for future generations of researchers to ask bigger, deeper, and more mind-bending questions about the universe. What once looked like a quiet, empty expanse now appeared full of life, motion, and drama. Webb revealed a cosmos that's not just big, it's rich, tangled, and constantly changing. The true scale of the universe isn't just about how far or how old it is, it's about how complex and connected everything is. In this way, Webb became more than just a telescope. It became our window into the universe's soul. It showed us that the cosmos isn't a still painting, but a living, breathing masterpiece. From the formation of the first stars to the swirling skies of distant exoplanets, Webb captured the universe in motion, revealing a reality more vibrant and dynamic than we ever imagined. And it didn't stop there. Every new image and data point pushed our understanding of the universe deeper. Webb helped scientists explore not just the edges of space and time, but the workings of cosmic environments, how galaxies form and evolve, how matter moves between them, and how energy pulses through the cosmos across vast scales. One of its most fascinating achievements, peering into the so-called empty space between galaxies, the intergalactic medium. Webb's powerful instruments picked up the faintest whispers of hydrogen and other elements drifting through this space. What once seemed like a cosmic void turned out to be a bustling highway of matter, influencing how galaxies take shape, interact, and grow. Webb could even detect how this intergalactic material has changed over billions of years, helping scientists trace the invisible threads that connect the universe like a vast web. It wasn't just mapping the stars, it was mapping the space between them, revealing the hidden structures that knit the cosmos together. With every new observation, Webb didn't just show us more of the universe, it reminded us how much more there is to learn. The universe, it turns out, is far from static. It's alive with evolution, soaked in complexity, and governed by forces we're only beginning to understand. And thanks to Webb, we're now closer than ever to unlocking its deepest secrets. Stretching across the universe like glowing threads, the cosmic web is made of thin filaments of gas that link galaxies over unimaginable distances. With its sharp vision, the James Webb Space Telescope brought these filaments into focus, revealing how they act as intergalactic supply chains, feeding galaxies with the raw materials they need to grow. Inside these delicate threads, Webb detected shifts in temperature, density, and chemical makeup, traces of how the universe recycles matter. As stars burn out and explode in spectacular supernovae, they hurl heavy elements into space, enriching these filaments with the building blocks of future stars and planets. Webb captured these moments mid-action, giving us a front-row seat to the cosmic cycle of creation and renewal. But it didn't stop at galaxies. Webb zoomed in on molecular clouds, the cold, dark nurseries where stars are born. What it found inside them was extraordinary. Not just simple gases, but complex organic molecules like methanol and formaldehyde, substances that resemble the early ingredients of life. Even more incredible, Webb detected these life-linked compounds in galaxies far beyond our own, hinting that the chemical seeds of life might be scattered across the universe. These discoveries opened a new window into astrochemistry, showing how complex molecules can form even in extreme conditions. Near blazing young stars or deep within harsh galactic centers, places once thought too wild for delicate chemistry, Webb found molecular reactions still thriving. It's a powerful reminder that the universe might be more chemically creative than we ever imagined. While Webb wasn't built to find life directly, it laid the foundation for future missions to do just that. It helped scientists pinpoint habitable zones, regions around stars where life-friendly conditions might exist, not just by measuring distance, but by understanding radiation levels, stellar activity, and other key ingredients. These insights helped paint a fuller picture of what makes a planet truly livable, expanding our definition of habitability far beyond Earth. In short, Webb isn't just showing us where we come from, it's helping us ask the biggest question of all. Are we alone? One of its most awe-inspiring contributions, revealing the incredible detail in the final stages of a star's life. As stars run out of fuel, they don't simply fade away, they go out in spectacular fashion. Using its powerful infrared vision, Webb captured these moments like never before. It showed how dying stars eject massive clouds of gas that don't just drift off, they form stunningly sculpted shapes, rings, shells, and even jets of material, carved by invisible forces like magnetic fields and stellar rotation. These vibrant structures aren't just beautiful, they're essential. They enrich space with elements that later help form new stars, planets, and even the ingredients for life. And when this material interacts with nearby clouds or stars, it can actually spark a new wave of star formation, proving that stellar death is often the beginning of something new. Webb also zoomed in on stellar nurseries, where massive young stars are just coming to life. It found powerful feedback loops, where intense radiation, stellar winds, and even supernova blasts from newborn giants can both create and destroy. Sometimes they compress gas clouds, jump-starting new stars. Other times, they blow everything apart, ending star birth in its tracks. These processes aren't simple. They're a cosmic balancing act. And thanks to Webb's precision, scientists can now simulate and predict them better than ever before. In short, Webb is helping us see that the life cycle of stars isn't a straight line. It's a complex, interconnected dance where endings feed new beginnings and destruction fuels creation.